Okay, so we have two pins and two bushings. The 28, and I believe the other one was 35, something like that. These are going to be the same, and this is where we can take advantage of the configuration. If you want to do the save as and open and have two separate files, that's fine. I want to just kind of reinforce the places that configurations will come in handy. If we're going to reuse this, this might be something that we put in the design library. And if we're using it across our product line and it's a common part, we'd want to make it accessible to all of the assemblies, all of the parts that we manufacture. So we are in a new part millimeter, and we have three methods of creating the configurations. The easiest of which is just to create a configuration, change the dimension, the physical properties. Also, I guess that would make it four, is we can right click on a feature and configure its properties. And then the next one would be to actually create a design table or utilize the equations. So um, let's go ahead with our shape. Don't see any reason to get too fancy, so let's just go with the circle. Trying to think if there's a reason why I'd want to do this as a revolve and can't come up with a good one. So 9.995. So pretty close. Let's see, if we round to a millimeter is 40 thousandths, 0.1 is 4 thousandths, 0.01 is 4/10 of a thousandth, 0.00. Yeah, you're down into the millionths of getting into 10 millionths on the diameter. So it'd be interesting to try to hold that. All right, so we'll go ahead and extrude boss base. Make this one 28 millimeters long, and that will set up for the default. All right, so when I'm doing this, we'll zoom to fit. And when I'm doing this, I'm going to set up, and let's go ahead and I'll scroll down, and the other one is 35 millimeters, so that is good. So I'm going to do, staying with the naming, and this is the pin, and I just put that value in, and it escaped me. All right, so pin 28. And then I'm also going to create a configuration for the pin 35. All right, so when I look at this name and it still says part 6 in the bill of materials, it's going to refer back to whatever I end up naming this. So what I want it to do is we need to go back to the properties and make sure that it is attached to the configuration name. Don't usually use custom names. If the user specified name and entering a value, if I go to the trouble of doing the configuration name and the description, I shouldn't have to do anything else to it. So now the part 6 in brackets goes away. It's using the configuration, and we'll just do the simple on this one. And still don't have anything to really get into the Excel file with, so we may, as optimization, do an Excel file with way more than we need. All right, so when I go to the feature and double click on the dimension, I'm going to, and if I double check over here in the title on the feature tree, I'm in the pin 35 configuration. If not, I would want to change that so that I can select this configuration, change it to 35, rebuild to update, and we're going to save this, and I'm just going to do this as the pin. Okay, so that gets 2 parts, and I want to double check. Pin 28 shrinks a little bit, and the default pin, again, the default I leave as the generic that I created everything with. Worst case, if I totally screw up one of these configurations, I can send it back to the default and start over. All right, so that takes care of our pin. Let's bring, we'll go ahead and save since the little asterisk was showing up there. We'll fly this back in, and we have the 2 bushings, or 1 bushing. All right, looks like 2 bushings. Oh, sorry, 1 bushing, so that doesn't even really come up with a configuration on that one. So 16.028, that gives us a little bit larger, and that will be determining our press fit into the part. So new for the bearing, and again, I don't can't think of anything. If this was a flanged bearing, or if I was doing a family of flange bearings, I might make this a revolve, but for just a straight, just for our straight, I'm not gonna worry about it. So 028 and accept, and then our clearance is at 10 millimeters. And when we right click and extrude, then we're going to make this a total of 18 millimeters and accept it. And I don't think I did the, oh, that's what I forgot. I was thinking about the configurations and not thinking about the part number. So our bearing becomes bearing BG 400-18. So that's kind of an interesting, they're calling it 3120. So we'll see if that exists. And then we'll go back and update for the, all right, so not seeing anything in there for, let's see if we have other metals, copper alloys. Well, I would think phosphorus bronze or tin bearing bronze for material. So I'll go look up 3120 and we'll revisit that one. Raw, modeled, and date. Okay, notice that the colors change, and we have that that look like a bearing material. Okay, so let's go up to the pin, and we're going to verify. So they're actually doing pin long, pin short. I think staying with the length is probably better. So the P10 for the ID, 35 for the length, and actually I'm in the default. So oops. I'm going to leave the default as is. Switch over to the pin 28. Did I not? Yeah, we can go ahead and save it. All right, so we're in the pin 28. P10-28. And the material, yeah, we still didn't, it's calling it 3120, but like I said, I would probably move more towards a stainless steel or something that would have the corrosion resistance and good wear resistance overall. but based on cost or a little more expense may not be. Well, let's just go back into the steels. So between those, either the 303 or the 304 would be a standard, and you can pick whatever you think would be best there. And we'll just apply that, make sure it all gets written into the properties. I think my patience is showing. Pin 35, come on. Okay, show configuration. And we switch back over, and then this is P10-35. We'll pick something different for this one, just to show the separations. Maybe the I was looking for a regular 316. All right, so that'll work. We'll see how that looks in the title block too, since it's a little bit longer name. And if we stay raw, apply. Now notice that these populated in because they were written into the properties, into the custom properties, and will carry over, where these will 35, and then if I switch over to 28, then I can check them as there. All right, so that takes care of the pin. Our next method, just to revisit this, is to go into the right click, configure the feature, and if I was doing the diameter, I could do that. I believe I could do that from both the sketch and the feature. Since this is a feature property that I'm using to control the length, I want to configure the feature at that level. And we're going to have the list. It already brought in D1, which is pretty much what I want to change. So if I went to pin 50, for example, and then change that value to 50. And this is all not required for the part, just a good example. I can go through and add as many as I need. So if I think I'm going to get much above 100 millimeter, I may want to go back and change the name, because sometimes, let's go ahead and apply it, hit OK, and see what it does in the configuration. Pen 100, anything in that sequence goes above, so maybe I'd want to call these 0.28s, and the longest that I would have would be a meter or whatever. So if it made it to 999, that would be our limit. So not a big deal, but just something to consider as far as making these sequential. All right, so that should be all of our components. We're ready to assemble.